Just looking at arranging in a circle with restriction. Okay, so let's just look at how many ways can you arrange 8 people in a circle if 2 particular people must be together. So focus in first on the restrictions. Okay, so the restrictions are 2 people must be together. So let's call them A and B, and let's plant them together. So there's your A and your B. Now, within themselves, they can be arranged in 2 factorial ways. And then if you look at the rest of the seats, because there were 2 people, there must be 6 left. So if you do 6 boxes, 1, 2, 3, 4, 5, 6, then that means that if there are 6 left, that means that can be done in 6 times 5 times 4 times 3 times 2 times 1. So that would be 2 factorial times 6 factorial. Now, if you did not want the 2 particular people to actually be together, then you need to do the total number of ways with no restrictions minus the fact that they are together. So that's going to be the total number of ways. If there's 8 people, you do 8 minus 1, which is 7. So that's going to be 7 factorial minus the 2 factorial, 6 factorial. Okay, so now let's just look at the next one. So the next one, C, 3 particular people must be together. So let's do our circle and let's put them together in a seat together. So that's going to be, let's go A, B, C. Now amongst themselves, that's 3 factorial. And then we've just got to seat the remaining. So if there's 8 people, there would be 5 remaining. Okay, so looking at that then, if there's 8 people, there's 5 remaining. So that's 5, 4, 3, 2, 1. So that ends up being 5 factorial times 3 factorial. That's what would be left. Okay. All right, so let's look at the next one, D. So with D, 2 people, Maya and Indy. Maya and Indy must be opposite each other. So if you put Maya and Indy opposite each other. Now here's the catch. There's Maya, there's Indy. Would that be different if I turn my circle around and I put Maya here and Indy there? Okay. Now, what about if I took Maya here and Indy there? Is that a different order at all? And you can see that it actually isn't. All we're doing is turning the circle around. They are still opposite each other. So therefore it does not count for another possibility. So if we put them together like that, that's only in one way. And then we have 8 minus the 2 of them leaves you 6 people. So you've got to put 3 on this side to make them opposite and 3 on that side. So when we're working that out, that means we have 6 people left. So it's 6, 5, 4, 3, 2, 1. So you just end up having 6. You end up having 6 factorial ways. Okay. All right, and now we've just got to look at the last one, which is the 4 boys and the 4 girls alternate. That's for E. So let's just I'll just put the yellow for the boys. And I'm going to do the green for the girls. Okay. Now, we could start with the boys or we could start with the girls. So let's start the yellow for the boys and the green for the girls. Okay, so doing yellow for the boys. So with the boys, there are 4 boys. So that's 4, 3, 2, 1. So we do our first boy and then that means the other 3 boys. Nope. Okay. If we look at that, is that actually correct? Now, because it is a circle, that actually is not correct. What we need to do is the first thing we need to do, like we do with all our restrictions, what we need to do is we need to fix a boy first. So if I fix a boy there, then that means the other boys have 3 places that they can be seated. So that's 3 times 2 times 1. So that means that the boys will be 1 less. That will be 3 factorial times 4 factorial. And then if you look at the girls, so the girls basically now have 4 seats to choose from. So we could put 4 different girls next to the first boy, or 3, or 2 in the next one, or 1. Because once you fix the boy, then it fixes everything else. So it's times 4 factorial. So what you notice here, it is only one of them that is 1 less. And so that one there is 1 less, the boys. Now, would it make any difference if I did the girls first? Is that actually a different... You got to think about, is it a different combination? Like if I fixed a girl first, is it actually giving me any different possible outcomes than if I did this? And I think the answer is no. You're actually still getting the same combinations, 2, 3, 2, 1, and then 4, 3, 2, 1. So it's still 4 factorial times 3 factorial, or 3 factorial times 4 factorial. And because it's a circle, it actually isn't another option. So that's just how you arrange people in a circle with different restrictions. I think the key to any of this is always do your restriction first and then seat the rest of them. So you always do the one that's, you focus in on the restriction, and then everybody else just kind of falls into place. And also with a circle, you need to fix one thing first and then do the rest. Whereas in a line, you fix one thing as a group. A line, the groups can move along the line. And then the other thing is, if the same as the line one, but if you have not together, then you do the total minus they are together.